Welcome everybody to week 11, day 1. We're going to be talking about two different topics today. We're going to have two different lectures. One is going to be on debugging. The other one is going to be on classes. So we're going to start off by talking about the two big ways of debugging a program. And I think for those of you that have been struggling on this homework assignment and not having a good time, it's because your debugging skills aren't up to speed. So good news, you're going to have 3 new homework assignments due on Friday. That is 2 days after the current assignment that are debugging assignments. They're not real programming assignments. They're done. Each one of the debugging assignments will have 2 bugs in them. One that is a compiler error, one that is a logic error. The compiler error will prevent it from compiling. For example, a missing semicolon, a missing curly brace, a missing parentheses, something like that. That's usually pretty easy to fix. That's half your points. The other points will be given for fixing the logic bug. A logic bug could be something like an infinite loop, or you're supposed to compute the area of a circle and you're computing the area of a square. There's 3 of them labeled midterm 40A, 40B, 40C. And the reason why they're named those is because they used to be midterm questions. Students used to be given about half an hour to do them, and now you're given 4 days to do it, or 2 days if you count it after the next homework assignment's due on Wednesday. Either way, plenty of time. Last semester, they were given 2 days to do it, and pretty much everyone was able to complete it. So let's talk about debugging. There's 2 different ways of debugging, like broadly speaking. There's 2 main approaches to debugging. And then debugging. These are GDB. In other words, use a debugger, and the other is cout all the things. So log things to the screen or to a file. These are kind of the 2 big, broad approaches to debugging things, other than just like constantly recompiling it and hoping it'll work this time, which if you've been working on a bug for 8 hours, at a certain point, you just start randomly changing things and compiling and praying, and that is not a good way to be, because then when the thing works, you have no confidence that your thing is actually correct because you were just randomly changing things. So let me show you both of these approaches. All right, so Serta's code here is segfaulting. So if we do this, we are getting a heap buffer overflow error. This means you've gone out of bounds. No, you're out of bounds on the heap. That means something that was nude memory. And so he is crashing on main.cc line 170, which is called from main.cc line 54. So if we go into main.cc line 54, and you can choose the line like that, plus 54, you can see that we're calling find path. And if we want to go to line 170, I'm type 170 shift G, and we can find the line. I think that was it, right? 170. Is that it? Yeah, 170. Okay. So main.cc line 170, right there. So that is where Serta is going out of bounds. Okay. Now we've got here 1, 2, 3, 4 different array accesses, and it could be any of those. Okay. So the question is, which one is out of bounds? And I think it could just be all of them. Okay. So if we're going to do this in GDB, then what we do is we first have to make sure your code is being compiled with debugging turned on. And it is, in fact. The -G there means that debugging is turned on. And if we want, we can delete the optimizer so that it doesn't like erase lines of our code. Make clean. Make will rebuild our project. And you can see that it is rebuilding it with a -G flag there, and the optimizer is turned off. There's also an optimizer flag called -OG, like you can do G++ -OG, that's supposed to be debugger friendly, but what I found in the previous class was that even with that on, it was actually deleting variables that I wanted to look at. So there you go. So for debugging with GDB, step A, compile with -G. This is done for you most of the time in this class, but it's important not to skip that step. And then the next thing you need to do is make clean, make if you changed the makefile. If not, skip this. And then finally, we're going to do 1c gdb a.out. And then after we run it, we're going to run it with a San Joaquin map or something, but we'll just type run, and maybe we'll do like something like that. So let me show what that looks like. So we're going to go gdb a.out, and we're going to run it. This time I'm not going to run it with a San Joaquin map. And we're going to type in starting row 300, and boom, there we go. So we got a crash. And so GDB allows us to examine the variables. So address sanitizer tells us which line it crashed on, but if we look at it and we're like, I'm not really sure why it's crashing, you know, it's telling us 170, whatever. Then we can use the power of GDB to find out what went wrong. So if we type backtrace like this, we need to turn off address sanitizer. It's getting in our way. So turn off asan here. Make gdb a.out. Run. Let's see, gdb. Okay. That's right. Run, and then row 300, and that's funny, it actually worked. So we went out of bounds, but it didn't cause a crash. So address sanitizer was actually finding us going out of bounds, but it did not trigger a crash. So GDB is not going to be very helpful here. So we can not watch Rick and Morty on this class. Get me in trouble with the dean. There we go. So here is the visualization, and you can see they are not tracing a route through the map. Okay. So, but that's the general process. Okay. So GDB didn't help us here because it actually didn't trigger a crash. Now, if we did this again, and let's see if I can trigger a crash by running it on the San Joaquin map, then we got a seg fault, okay? And so GDB tells us that main.cc line 167, and if you want to see what line 167 is, you can actually switch into 2E mode with Control-X, Control-A, and it can actually show you which line of code that you are on. You can do things like print out what value is east. Print east. And east is negative 3,624. That's a problem. You should never have a negative index into an array. So that's a problem. So east is, I think, the elevation. And that's probably the elevation too. So what they've done here is they're grabbing the elevation data and they're using the elevation as an index into the array, which is just wrong, right? Like, you know, if something is like 50,000 meters above sea level, you don't go to array address 50,000. Like, that's just wrong, right? So, yeah. This line here doesn't do anything at all, interestingly enough. That doesn't do anything. That's just, it's going to load the value from the array, and then it's going to do nothing with it. This one is loading data from the array and causing us to go out of bounds and saving the value into var. Neither of these two lines actually do anything. This line here does something. So this is actually setting the current tile's value to be -1, which is what you need to do. As you travel through the map, you need to be setting your current tile's value to -1 after you're done with it. You're going to essentially carve the mountains down to -1 elevation because the renderer, the thing that draws that picture to the screen, takes any elevation -1 and puts a purple line there. So yeah, all of these things are highly suspect right here. Highly suspect. Okay. So another example of this, let's see if they've fixed their code since then. GDB a.out, run San Joaquin. Nope. Okay, so their code is going out of bounds as well. All right. New. I think they might have fixed it actually. Let's see if I find somebody else's code. Anyone else's code crashing right now on San Joaquin? And pull. I think they've actually fixed it, so I don't want to show you their code because they probably have the answer to it in there already. Dermer? Okay. Let's do a little bit of live debugging. CD into bridges, now times 40. And I'll take a look at your makefile. And again, I'm just gonna, I'll just run this. Okay, starting row 300. And you are crashing. Okay, so GDB, get it out, run 300, backtrace. And so you are crashing line 59 in main.cc, calls getImage. On line 121. Line 121 is calling color, calling set value, set red, and then it is throwing an exception in here. Okay, so if we go up to, and it looks like these values are actually optimized away. So we're probably gonna have to recompile with the optimizer turned off. Turn off the optimizer, leave address sanitizer on for now. Make clean, make. You only have to do that when you edit the make file. Normally you don't have to do make clean and a make, just make is fine. And make figures out what needs to be done to build your project and builds it. So if I type make again, you'll see it says nothing needs to be done because you don't need to do anything else because it's already built already. Okay. So we're gonna run it, row 300, and it quit. Okay, so GDB, get it out, and we're gonna run it. And we're going to do a backtrace, and there, now we have the values. You see what happened before? The values were optimized away. Okay, so I'll refresh it up at the top of the screen here. So you can see that your code main is calling getImage. That's not null, that's fine. The width and height look fine to me. Max value is fine to me. But you are creating a color whose red value is -1, whose green value is -1, whose blue value is -1, and whose alpha is 255. Can colors be negative? That's not good. I agree, it's not good. It's probably the source of the crash. And if you're like, well, you know, it's not my code that's crashing, it's the bridges code that's crashing, right? Because, you know, you can see the crash is actually coming out of bridges. Yeah, it is, but it's crashing because you violated the contract. Their code only takes values from 0 to 255 for red, green, and blue, and alpha. And you're passing a -1 to it. If you pass in a -1 color to it, they can do anything they want, including crashing, which is what they're doing. Personally, if I was writing this code, I would just have it, you know, print a message like, we don't take negative colors around here, you know, things like that. But they're within the rights to just simply throw an exception and kill the program because they're asserting that, you know, colors have to be positive, which they do. Yep. So there you go. So that is the GDB method of debugging. And I'm just going to tell you right now, if you pass a negative color into bridges, it will segfault. So that's the GDB method. The Cout method is like this. So we come in here, and we've got all this kind of code here. And let's come up here, and we will Cout 1. This is a really not very good way of doing it, by the way, but it amuses me. Cout 2. Cout 3. Cout 4. Why am I printing out a number before each one of these functions here? What's the purpose of all this? See where it breaks, exactly. So the end line, by the way, end line flushes the output buffer. When you output an end line, it will guaranteed print to the screen. If you don't have an end line in there, when your code crashes, it's possible your Cout's not going to appear. So when you are doing debugging, you want to really be sure you do an inline every time. Even if you're used to doing like \n, use an inline. It's good for you. So, okay, we got there and we got here. And so we got to number 5 before it crashed, okay? So we got to 5, we didn't get to 6, so we can tell we are crashing on this line right here. You guys see how that works? Yeah. Is that faster than GDB? Yeah, sometimes maybe. Like I can debug things using Couts pretty quickly, and this is assuming I have no knowledge of like where the thing's dying. Like if I have some clue, like if I've been developing all along, I usually have a pretty good idea what line it's dying on, and I don't need to scatter these seeds across the entire program. I can just, you know, probably just go right into get image like immediately, right? So we're gonna do the same thing here. So we're gonna do Cout1, and that guy needs a curly brace. This for loop doesn't have a curly brace on it by default, which makes it annoying. Okay, so Cout2, because you can't put this line here without a curly brace. And then we'll do actually let's move 2 to here, and then we'll come into here. We'll do a, because we're in a branch, we'll call this like 4A, like 4B, and then like, I don't know, Cout5. This is, like I said, this isn't exactly how I debug it, but it kind of like conveys the point to you guys. So we're going to compile, run, and see how it goes. Because we know the code's crashing somewhere within there, right? So you see it's going, it's running through the for loop, and it's crashing within 4B. Okay, cool. Neat. So we can take this out, take this out, take this out, take that out. Yeah. Okay, so 1, 2, 3. And in fact, at this point, I'm probably not going to do these like super like low usefulness Cout statements. I'm actually going to probably print the values. So I'm going to Cout pixel value, because I might be getting like a divide by 0 here. You know what I mean? So I'm going to print out the values before I do that in case there's a divide by 0. So I'm going to Cout pixel value, and I'll Cout max value. And then after we do that, I'm going to Cout gray. And after I do that, I'll just Cout like, I don't know, done or something. I don't think I need you anymore. Oops. Compile using make pix value. Yeah, fair enough, fair enough, fair enough. Pix value should be pixel value. Thank you very much. Make. MK is an alias for make. Clears the screen and then rebuilds. If you want to compile this by hand, you can do so, but there's a library that needs to be included for bridges to work. So it's usually better to do make. So we'll do that. So you can see it's like cruising around, cruising around, cruising around. Stuff's happening. Aha. Look at that. So that is the pixel value. So that is the elevation that is causing it to crash. So the max height is 4,015 meters for everything. Everything's working fine until we encounter a tile that has a negative elevation to it. So what does this tell us? What's the bug? And it's arguably a bug in bridges, you know. I mean, yeah, but it's your code now, so it's your bug to fix. So what's going on here? What's the assumption that was made behind this code? Because I didn't write that code. It's your code now. You're responsible for it. There is a negative value inside of the map. Yeah, what does it mean for there to be a negative value when you have a height topological map like this? And what assumption was made when writing this code? The name of the assignment is mountains. Hang on. Okay. So, yes, that is correct. They made the assumption that there would not be any elevations below sea level. Colors can't be negative, right? But elevations can be, right? And if you just, this is something I talked about on like the first day of school, right? The assumptions, the things you don't think about are the things that get you, right? Like, it's hard to think about things you don't think about because you're not thinking about them, right? And so, like, if you just kind of assume that all elevations are going to be above sea level, then you sort of implicitly bake those assumptions into your code, and then you get a crash, right? Like this. And so the assumption was that just nothing would be below sea level. So when we got something below sea level, you know, there you go. And the code crashes. So you need to handle negative elevations. And so the way I do it is by having the color instead of be like that grayscale kind of thing. What I do is I make a blue. I make like a sea blue or something like that. Then when you're done with the sea outs, you just pull them out and you're done. So we've identified the bug and we know what to do now. So there's different ways of fixing it. You could just like clamp the value so that if the pixel value is less than 0, it's equal to 0 and it just draws as black. There's a lot of ways. Once you understand what the problem is, it's easy to fix. But the trouble is getting to this point, right? Getting to the point where like you know why the code's crashing. Especially because you're like, well, I didn't write that code. And obviously code that I don't write can't crash, right? No. there's bugs everywhere, right? And so the GDB approach is one way of finding it. And we could see that it was passing in -1R, -1G, -1B as the color, causing the crash. Another way we can do it is using couts. And so these two methods, you can just use whichever one you want. Cout all the things or GDB. They both work. My personal preference is like if I'm actively writing code, then I'll typically put cout statements. And then when I run the code, I can just see the code kind of as it's running. Like the current value is 5.5, the current value is 5.6, the current value is 5.7. And I can just sit there and watch it run and be like, oh, that's wrong, you know, and then I fix it. If I'm getting a crashing bug, then I typically run it through GDB because when it crashes, GDB will allow you to do a post-mortem and it'll allow you to see all the values of all your variables at the moment of death. And you're like, I had a negative color there. That's probably why it's dead. You know what I mean? Using backtrace is really helpful. Backtrace will tell you all the functions that called functions, that called functions, that called functions, that called functions. And if you want to go up to stack level 10, you can type up 10. That takes you up to stack level 10. You can print out you can print X, print Y, print C. And that's all super useful stuff. 2E mode, if you like GDB in 2E mode, I think it's 2E, 8 out, like that. And so it'll take you into text user interface mode like that. And you can set a breakpoint on line 25, hit run. It'll run until line 25 is reached. You know, it's really, really useful to get good at GDB. And but GDB takes a while to start up, and you know, a lot of times I can just throw like some cout statements into my code, or if I'm in a real program, I log it to a file, and I can just look at the log and immediately be like, that's the problem, without having to sit there and, you know, set a breakpoint and run it and kind of like step through it and stuff like that. After a while, you'll build up your skill. Like learning how to debug things is a skill that you will build up over time. And it's what separates new programmers from experienced programmers. It's one of the things that separates us, because experienced programmers still make mistakes, and we make dumb mistakes too. Like we'll forget a semicolon. So it happens. Like it does. It really does. Like, you know, like I typed the wrong variable name, you know. But the thing is, like, we don't get stuck on the stupid error, right? Whereas new programmers oftentimes will. You have, you know, you screw up a for loop, and, you know, you do a copy paste and you forget to change one of the variables when you copy and paste a for loop, and then the thing runs infinitely. A new programmer might just be like, I don't know what's happening, and they just stare blankly at the screen. It's not working. I don't know why. And they just quit it and run it again. And it runs infinitely again. They're like, I don't know. And they stare blankly at the screen. They're like, I don't know what's going on, man. Like, you know, it looks fine to me. Whereas an experienced programmer will be able to very quickly identify like, oh, that second K there, you know, like let's say that this was a J instead of a K, right? If K doesn't increment, then this thing is going to run forever. You know what I mean? Like if that's a J instead of a K, copy paste there, right? You copy and paste, you change that to a K, that to a K, you forget to change that to a K, then you've got yourself an infinite loop and this thing will run forever. And so experienced programmers who've probably done that mistake many times will instantly be able to recognize it. If not, we put in some cout statements. We see, oh, we're looping infinitely here. And then if we can't figure out why, we'll cout J, we'll cout K. We're like, oh, look, K is not going up. Oh, that's why. It's not plus plussing. And we can just quickly find what's going on, and then we go back to developing code again, whereas new programmers will get stuck. Like they'll be coding, the thing doesn't work, and they get stuck, and they don't know how to proceed. They don't know how to find the bug. And the longer you spend debugging, the less time you have to spend coding and actually writing code and solving your problems. And so if you can take your debugging time from 8 hours down to 10 minutes, that's a massive increase in productivity, right? Like if this project was going to take you 16 hours and half of it was debugging, you've just doubled your productivity, right? And this is one of the things that, like, you know, some programmers will mock, like the notion that there can be a programmer that is 3 times, you know, better than another programmer. But like, yeah, they can be. They really can, because if you're spending all of your time staring at your code, trying to figure out why it's not working, the other guy is like out there still writing code, and his code's probably going to make the same mistakes as yours. Like he's going to forget semicolons, and he's going to type variable names in wrong, and you know, but he just instantly fixes it and then goes back into writing it. And that is a massive difference in productivity when it comes to like overall, like at the end of the work week, how much have you accomplished? This person's done 3 times as much as you, quite easily. It's quite possible. And you know, especially when you're a really beginner programmer, like you're talking like an order of magnitude difference in productivity. You know, so debugging is a really, really important skill to know. And to that end, you must do the new homework assignment, which is cd midterm 40a main.cc. So here you got some code, and this code has got 2 problems in it, one of which is a compiler error, one of which is a logic error. And so there's a README file in each of these files that tells you what it should be doing. And I don't want to spoil this one for you, but like, I don't know, this looks fine to me. Let's try compiling it. G++ main.cc. Expected a semicolon. Oh, I don't know. I'm not going to tell you guys what's missing here, but like the compiler is like going to give you a pretty good hint as to why it's not compiling. Okay. You get that done? That's 1 point on your homework assignment. Okay. So, yeah, I don't want to spoil it for you, but there's something missing on line 20. Okay. Then after you get the compiler bug fixed, then you need to look at the README file, and it's going to tell you like, it should be like printing out a times table or something like this, and it's not. So you can figure that out. So like, look at what it's actually printing out, look at what it should be, fix the code until it matches, and then you're good. Then that's another point. Then you move on to midterm 40B, 2 points there, 40C, 2 points there. It's a fun little exercise. It won't take you very long at all, unless it does, in which case it shouldn't. So it's good for you too. So if it does take you a long time, that's a sign that you should like work on your debugging skills. And if you guys like these, then we'll do some more probably next week as well, because debugging is important. Okay, any questions about this before we move on to talking about classes? Anyone know what is missing on line 20 here? You can see it on chat. I'm not going to repeat it on the recording. What emoji is that? The assignment is due on Friday. So you have 2 days after Bridges Mountains to do 3 homework assignments, each one of which is worth 2 points. They're real easy. Okay. So, but they're going to work on your debugging skills. So they're fully written. There's exactly 2 bugs in each one, a compiler bug and a logic bug. and each one of them is like pretty much like a single word or a single character sometimes fixed, or a single line that needs to be fixed. Like if you're writing more than like a line of code to fix it, you're probably doing it wrong. So none of them will require more than a line to be changed. Okay, so that's it for debugging. Let's switch over to classes.